Welcome to another math problem of the week. 3 partition, power of 3. Let's talk about it. Now for this question, we need a little bit of definition. For any positive integer n, a 3 partition of n is a list of power of 3 arranged in order from greatest to least whose sum is n. For example, when n equals to 6, it can be written as 3 plus 3, 3 plus 1 plus 1 plus 1, or 1 plus 1 plus 1 plus 1 plus 1 plus 1. Each of the number is a power of 3 and the arrangement is from the greatest to the least. So the question is, how many different 3 partitions of 29 are there? And the options are A, 21, B, 22, C, 23, and D, 24. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
We try to understand this question using this example again. So for 6, it can be written as 3 of A plus B for some non-negative integer A and B. Example, 3 of 2 plus 0, or 3 of 1 plus 3, or 3 of 0 plus 6. And this corresponding to the first arrangement, the second arrangement, and the third arrangement. So we will say that the answer for this will be AB equals to 2, 0, 1, 3, and 0, 6. Please do not confuse with the arrangement here, where all the number must be of power of 3. So now we will write 29 into 27 of A plus 9 of B plus 3 of C and plus D. So this question is equivalent to ask how many non-negative integer A, B, C, D that satisfy this equation. Note that the A is not more than 1. When A is equal to 1, then B has to be equal to 0, C has to be equal to 0, and D has to be equal to 2. And we know that there is some nice observation. Let's say you have A1, A2, AK, AK plus 1. If this is one of the possible solutions for the 3 partition, then we will note that A1, A2, all the way to AK minus 1 if AK is greater than or equal to 1, and AK plus 1 plus 3 will be also one possible 3 partition. So let's say for this, when 2 become 1, the following terms will add by a 3. When 1 becomes 0, the following term will add by 3. If you enjoyed this video, please like, comment, and subscribe. So using this notation, we can actually list out everything. This will be equals to 0, 3, 0, 2. Meaning that A equals to 0, B equals to 3, C equals to 0, and D equals to 2. And if we minus 1 here again, then this will be equal to 3. And if we minus 1 again, this will be equals to 6. And we can continue, this will be equals to a 9. Now we focus on here. If we have 0 and 2 and change the 3 to 2, then this will be a 5. And if we have 0 to 2, this change to 1, then this will be 8. And if we have 0 and 2, this change to 0, then this will be 11. If we have 0 and 1, this can be changed from 5 with some number which is not so important, and to 4, what number is not so important. It can be all the way to 0, 1, 0, and with some number. Likewise, for this, it can change from 0, 0, 8, some number, 0, 0, 7, some number, all the way to 0, 0, 0, and some number. And we know that they are all together 10 arrangement here. And for this, they're all together 7 arrangement. And for these, they're all together 4 arrangement. And we have 1 arrangement here and 1 arrangement there. So there are 2 arrangement for both. So the total will be 2 plus 4 plus 7 plus 10. That will be equal to 23. So 23 will be the answer for this question. And for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.